So for all these integrals on this problem set, we'll be using u substitution. So the idea behind choosing a suitable u is that we want to have a u substitution such that the derivative of u is also found within the integral. So in this case, choosing u equals x to the fourth plus 2 is very suitable because that simplifies our integral a lot. And it also, the derivative of u is 4x cubed, right? Which is also inside the integral. And so we know that will cancel out nicely. If we try to figure out what dx is here, that's the next step, right? We'll find that dx equals 1 over 4x cubed du. And then if we substitute all of this into our original integral, then we'll get the integral of 4x cubed. Then x to the fourth plus 2 is u. X to the fourth plus 2 is u. And so this is u cubed, and dx is 1 over 4x cubed du. And so this makes the 4x cubed cancel out. So we're left with the integral of u cubed du, which is 1/4 u to the fourth plus c. And then now we would just finally plug in x for our answer. We'd get this. So because it's an indefinite integral, we always have to have a plus c, and the final answer should be in terms of the original variable, not u. Next, for this one, you can choose either u to be sine or cosine. Both would work. I'm going to choose u to be sine. And then du dx here is cosine x, which means that dx equals 1 over cosine x du. If I make these substitutions, okay, we not only want to substitute for x and u, but we also want to substitute the limits of integration. So we're going to plug in these x values and change them into u values. So sine 0 is 0, and sine pi over 2 is 1, so that's how it would change. Now sine x is u, cosine x we keep there, and then dx is replaced by 1 over cosine x du. These cancel, so we're left with the integral of 0 to 1 u du, which is 1/2 u squared. This is a definite integral, right? So we're going to put in the limits of integration, 1 and 0. And then if we do this, it'll be just 1/2 minus 0, which is 1/2. Next one, here you should choose as x cubed plus 1, which means that du dx is 3x squared, which tells us that du is equal to 3x squared dx, which is exactly what we have here, right? This is 3x squared dx, which means that we can rewrite this as 1 over u squared, and then 3x squared dx is du. So this is also, right, we can only integrate normal powers of u, so we want to change this to a u to the -2 before integrating. And this will leave us with negative u to the -1 plus c, which is -1 over x cubed plus 1 plus c. Next one, here u should be 4 minus x squared, which means that du dx is -2x, which means that dx equals 1 over -2x du. All right, so plugging this in, we also want to change the limits, right? So we plug in x equals 0, we get u equals 4. Plug in x equals 2, we should get u equals 0. And this becomes u. And square root 4 minus x squared is square u, so this is u to the 1/2. And then dx we replace with 1 over -2x du. So this becomes 4, 0. -1/2 remains, the x's cancel out. we're going to have u to the 1/2 du. So the integral of u to the 1/2 is going to be, right, 1/2 plus 1 is 3/2. So the coefficient is 2/3, and the new power is 3/2. And we'll have from 4 to 0. So we first want to plug in 0. That'll give us 0. And then we want to subtract, plug in 4. So that'll be negative, negative, or positive 1/2 times 2/3 times 4 to the 3/2, which is 1/3 times 4 to the 3/2 is 8. So the answer is 8/3. Next one, here u would be x to the 4th, which means that du dx is 4x cubed, which means that dx equals 1 over 4x cubed du. And so if we plug this in, we're going to have x cubed cosecant squared x to the 4th 1 over 4x cubed du, which means that this is integral of 1/4. Sorry, I should replace the x to the 4th with u, right? So this is 1/4 cosecant squared u du. What is the integral of cosecant squared? Well, that should be memorized. It's going to be negative cotangent, because the derivative of cotangent is negative cosecant. So the integral of cosecant squared is going to be negative cotangent. That's our integral, and we should have a plus c because this is indefinite. And finally, we'll replace u with what it originally was. And that's our answer. Next one. Something more tricky. You should recognize that secant squared is just the derivative of tangent, right? And so that means that we're going to want our u to be tangent, which means that du will be equal to secant squared dx, which is exactly what we have here, right? So that means we can replace all this. The limits of integration are going to change to 0 and 1 because tangent pi over 4 is 1 and tangent 0 is 0. And so this is u cubed, and then secant squared dx is just going to be du. So this is 1/4 u to the 4th from 0 to 1, and that is just equal to 1/4. Next, here u should be equal to x to the 6 plus 4, which means that du dx equals 6x to the 5th, which means that dx equals 1 over 6x to the 5th du. When we plug this in, we'll get x to the 5th on top over square root u, right? Because x to the 6 plus 4 is u. Then dx will replace with 1 over 6x to the 5th du. X to the 5th cancels out. So we're left with 1/6. And then I'm going to rewrite this 1 over square root u as u to the negative half. Guys, can you be quiet? It's my voice that I need to have, right? I'm recording. Yeah. Okay, then the power of negative half will raise by 1. And so the integral of u to the negative half is 1/6, and then times the coefficient of 2, because it's 1 over 1/2, which is 2. So it's 2u to the 1/2 plus c. So we have 1/3 u to the 1/2, and u is originally x to the 6 plus 4. So we're left with that as our final answer. And we should have a plus c because this is an indefinite integral. Final question. In this case, u should be sine because the derivative of sine is cosine, and then cosine dx is found right there. So that would be a good substitution to have. So if u is sine x, then du is equal to cosine x dx, which is exactly that. So we'll be left with integral of something, and then we're going to want to plug in pi over 6 and pi over 2 into u equals sine x. And then sine pi over 6 is 1/2, and sine pi over 2 is 1. So the limits change to 1/2 and 1. And then cosine dx is du. So we have du over, and sine x is u, so this is u to the fourth in the denominator. We can rewrite this as u to the negative fourth du. And so if we integrate this, we raise the power by 1, so -4 goes to -3, and then we take the reciprocal of that, so it's -1/3. And so it's -1/3 u to the -3, and the limits are 1 and 1/2. So if we calculate this, this is -1/3 minus -1/3 times 1/2 to the -3 power. And so that is -1/3 plus 1/3. And then 1/2 to the -3 is actually 8, because the negative power is a reciprocal, and 2 to the 3 is 8. So that leaves us with 8. So the answer is 8/3 minus 1/3, which is 7/3.